All right, quadratic test number 2. Item number 2 is specifically in intercept form. First things first I want you to pull off are what are the x-intercepts. It's always x minus p, x minus q, and the p and q are our intercepts, so it's going to be 2. I don't want to write it as an ordered pair. 2 and negative 4. So first thing we're going to do is put that 2 and the negative 4 on our graphs as the x-intercepts. There's different ways you can go about finding the vertex because you need to have that in here too. There's different ways you can go about finding the vertex, but what I suggest to do in this case is, since we know the x-intercepts, find the line of symmetry between them. And I'm seeing that the line of symmetry between them goes through x is negative 1. And so if x is negative 1 at the vertex, what I need to do is evaluate the function for negative 1. So y is going to be, this is the vertex y. Y is going to be negative 1 minus 2, that quantity, times negative 1 plus 4. So the y value of the vertex is negative 3 times 3. So the y value of the vertex is going to be sitting at negative 9. So the vertex is 1, negative 9. I was looking for these pieces. And I'm going to come down here and put in negative 9. Now the y-intercept is when x equals 0. So you can go at this a couple ways, but I think the easiest is just to put in x is 0. So I'm going to have negative 2 times 4. It's going to hit the y-axis at negative 8. I was looking for each one of those pieces. And then once you have your negative 8, this is actually forcing you to have 5 points on this parabola. I think in number 1 you graphed with 3. I am intending to reassess intercept form on your final exam. Problem number 3 is next. Problem number 3 asks us to take a graph and write a quadratic. Problem number 3 asks us to take this graph and write a quadratic that goes along with it. And I pointed out that your vertex HK is sitting at 5, 1. And I wanted you to use the point 9 and negative 7. So this is an x and y pair. Now in vertex form, it's going to be y equals a times the quantity x minus h squared plus k. And our work comes in having to go find the a value. My work comes in having to go and figure out what is a. Now this is where we can use the x, y we're given, plug it in, and have it help us do the math here for a. And the x value is 9. So I'm just replacing x and y in this, and I'm going to go look for a so I can put a value there. I'm going to do the math. A, 9 minus 5 is 4 squared plus 1. I'm going to do a couple things right here. I'm going to take 1 away from both sides. Get negative 8. I'm going to square 4 and get 16. A, or a times 16. I'm going to divide both sides by 16. A is negative 1/2. This went better on the test, but not great. Expect an item like this on your exam. Number 4, simplify the radical expression. I want you to rewrite this. This was an interesting one that was a common error here. I saw a lot of people do this, but then for whatever reason put a symbol back, a radical back over there. I don't know why. When we look at this at this point, radical 100 is 10. Radical 81 is 9. We're done. We're done. The other one I'm going to actually put a star by only because it's relevant when I move on to number 9. But number 6 is actually the same problem, the same quadratic that number 9 is. And factoring this one, we need to have an x minus and an x plus. And messing around with the numbers that make negative 32 that add to positive 4. If I'm thinking correctly, I think it was positive 8 times negative 4. Because that would give us negative 32. And negative 4 plus 8 is positive 4.